Hi guys, it's Mrs. Antos. Hope you guys are enjoying remote learning. So far, I am so proud of you guys. We have had 100% turn-in. You are the only class so far that has had 100% turn-in, within the due date or very close to the due date and due time. So I'm very proud of you guys. Let's keep it up. Just be proud of yourself for that. So we are going to cover the next few sections in the book. We're going to cover 9.4. For the first few slides, I'm going to use a PowerPoint slide that I would normally show you in class. I'm going to zoom in for you guys a little bit. The first one we're going to do is 9.4. It's called Real Numbers. Oh, by the way, you should be taking notes just like you normally would in class. I know I've said that before, but just want to make sure you know it. Okay, so a couple definitions. I didn't want to write these all out, but make sure you write them in your notes, okay? So we already know what a rational number is. We've talked about this before, but a rational number is a number that can be written as a quotient of two integers. That's a fancy way of saying it can be written as a fraction. Okay, so it's nothing more, nothing less. An irrational number, so it's going to be the opposite of that, is a number that cannot be written as a quotient of two integers. Another important thing about this is that irrational numbers do not terminate and they do not repeat. So if they're in decimal form, which all irrational numbers can end up in decimal form, it's non-repeating and it's not terminating. One number I can think of right off the bat would be pi, okay? And then finally, real numbers. Real numbers consist of all rational and irrational numbers. Okay. Sorry, my chair's real squeaky. All right, the next slide that I want you to jot down is this graph here, okay? Or this chart. This chart talks about number sets. And it looks like a Venn diagram where there's parts inside of another. So if you look at this Venn diagram, you have this big box here represents all of the real numbers. So all real numbers will fall in this green area, okay? Part of the real numbers that are kind of separate into themselves are called irrational numbers. So that's like a separate circle that does not intersect with the other ones. Those are called irrational numbers. What I just mentioned, they can't be written as fractions. And two irrational numbers that pop up in my mind right off the bat are pi and the square root of 2. If you were to change those to decimals, they would never end and they would constantly, or they would not repeat, I should say. Excuse me. Okay, now the next portion of this diagram show numbers that we're used to working with quite a bit. So the first one are natural numbers. So think about the word natural. The way I remember this is I say, oh, it's natural to start counting at 1. So natural numbers are 1, 2, 3. They're whole numbers starting with 1. Okay. The next circle you have, the pink one or fuchsia, those are called whole numbers. It's the same thing, but now there's a 0 in it. So whole numbers are 0, 1, 2, 3, 4, so on and so forth. Okay, they're also known as, whole numbers. Okay, then the next box or circle, I don't know if you can see that, says integers. So now integers, if we remember, integers are positive and negative whole numbers. So now we have those same numbers in there from the previous two circles, but now we're adding negatives to it. And then last but not least, are rational numbers. Those are numbers that aren't whole numbers. They could be whole numbers, but also numbers that aren't whole numbers that are either fractions or decimals that end and repeat. Okay? So, we're going to look at some examples of real numbers and also irrational numbers and kind of decide on how to classify the different things. So the first thing we're going to talk about is classifying real numbers. Whoopsie daisy. We're going to look at each number. So we're going to make some columns here. We're going to look at numbers. We're going to look at them as decimals. We're going to look at them as the type of decimal. And then finally, the type of number we have. So we're going to refer back to this chart. Oh boy. Okay. So if I start off with the number 5/8, I have to figure out how to write 5/8 as a decimal. So I'm going to take 5 divided by 8. I can either put this in a calculator, I can do it by hand. When I do that, I get, hold on, I'm calculating it because of course I don't have a calculator. Why would I have a calculator with me?